Professor Alan M. Nathan from University of Illinois discussed baseball and physics. You can observe a lot by watching. For those people who have ever played baseball or understand the rules, they know that it is a relatively simple sport. However, during Professor Nathan's talk, he was able to look at a different side of baseball, the physics side. Have you ever wondered why a bat breaks or why a curveball can have such an odd motion? Well, Professor Allen was able to discuss why that is. Some of the topics he discussed were the dynamics of bat and ball collisions, also the flight of a baseball, such as its drag and lift. Baseball players can often feel if they've hit the ball just right, and this can actually be explained by physics. In the two clips, you see two different hits. One is just right, and the ball flies off perfectly. In the other hit, the ball is hit too far inside, which causes the bat to literally bend. Professor Nathan explained that this sweet spot is created when vibrations are minimized, the coefficient of restitution is maximized, and the BBS is also maximized. The batted ball speed, or BBS, is determined by the pitch speed, bat speed, and collision efficiency. The velocity of the bat, however, is much more important than the velocity of the pitch. For each extra mph of velocity of the bat gains an extra 6 feet. The coefficient of restitution, or the bounciness of the ball, shows how much energy will be lost during the hit. Also discussed in the lecture was the movement of the ball after being pitched, or after being hit. There are several forces acting on the ball, such as drag, which slows it down, and magnets and gravity, which deflect the ball from hitting a straight line. This graph shows with the blue dotted line, ideally where the ball would rise and land. However, the other two lines show where it actually could land. The fact that spin can change the movement of the ball is key in pitching because, like the chart shows, a breaking ball can be very tricky to gauge when it's not coming at you in a straight line. Something that Professor Allen didn't go into extreme detail on was the idea of different types of pitches, the knuckleball, the curveball, and how their different uses of spin can change their projection. The four-seam fastball is the most accurate and straightest pitch. Because of its accuracy and ability to get up to high speeds, it's the most common pitch in baseball. Next is the changeup, which is very popular amongst younger players. It drops to the right when it's thrown by a right-handed player. It's also slower than the fastball because the pitcher grips it deep in the palm of his hand. Next is the curveball. The pitcher comes over the top with his arm, throwing the ball down. The ball curves in to the left for a right-handed pitcher. The final pitch is the knuckleball. It's considered to be one of the most uncertain pitches in baseball, not only because of its level of difficulty to throw, but also because of how difficult it is to hit due to its oscillating motion. Having played softball for 12 years, I chose this topic because this sport means something to me, so hopefully you got to learn something too.